All right, well, the subject of lesson 10.3 is probability and odds. Probability is the likelihood of an event occurring, and when we are asked to find probability, which is what we're asked to do in 1 through 8 on the worksheet, we want to use the formula, the number of outcomes desired divided by the total number of outcomes that are possible. So they set up a scenario for us. You have an equally likely chance of choosing any integer from 1 through 30. I'm sorry, 1 through 80. They want you to find the probability of the given event that they describe in each of these numbers. So we're going to choose any integer, 1 through 80, but in number 1, we want to choose an odd number. So what is the probability that an odd number is going to be chosen? So what we do is follow our formula. We have the number of outcomes that we desire. If we're talking about odd numbers only, 1 through 80, well, half of them are going to be odd. So that there are 40 outcomes that we desire in this scenario. Out of the total number of outcomes possible, well, we have 80 integers to choose from, so there are 80 possibilities that could happen. So 40 over 80, or when we reduce it, the probability is 1 out of 2. So 1 out of 2 possibilities. For every 2 outcomes that are possible, one of them will be the one that we desire. All right, if we move on to number 2, a number greater than 50 is chosen. So we want a number that is greater than 50. That's our desire. There are 30 numbers greater than 50. So we'll put that on the top in the numerator. The total number of outcomes doesn't change. It's still 80. We still have an 80 possible choices that could come up. Reduce that down to 3 out of 8. So out of 8 outcomes possible, 3 of them are going to be the one that we desire. Number 3, a perfect square is chosen. Well, this of course means that you have to know your perfect squares. So perfect squares, I'll just list them out over here. And keeping in mind that we aren't interested in any perfect square that is over 80, greater than 80. So we get right here, we see that 64 is the last perfect square that falls within that range, 1 through 80, and there are 8 of them. So 8 is our number of desired outcomes out of, again, the 80 total. Reduce that down. So 1 out of 10, one desired outcome out of every 10 possibilities. Same thing with the perfect cube. You need to know your perfect cubes. So we're interested in the cubes up to and not over the number 80. So we see here we don't have quite as many, of course. So we've got these 4 outcomes that we desire out of a possible number of 80 outcomes. And then again, we're going to reduce it. So we could say 4 out of every 80, or it's just a little clearer once we reduce it to say there's 1 desired outcome out of every 20 possibilities. So now moving down the page, we're moving into odds. So up here in the directions, they actually, in 1 through 8, if you go back there just for a minute, they actually asked you to find the probability. So they're going to tell you whether they want you to find probability or odds. So in 9 through 14, they say find the odds. And they've just switched scenarios on us. Now we're rolling a 20-sided die where the sides are numbered 1 through 20. So now we're just moving into this idea that we don't have 1 through 80 as possibilities. Now we have 1 through 20. Odds, though, are a little bit different because we can have odds in favor of an event occurring, or we can have odds against an event occurring. So I've got in blue over here the idea of odds in favor, and in green the idea of odds against. So if you have odds in favor, if they ask you for that, and you can look down here through these directions. Number 9, they ask us for odds in favor. Number 10, in favor. Number 11 is against, as well as 12 is against. So you've got to, your first step when they ask you to find odds is which one are they asking you for? Are they asking you to find the measure of an event happening in favor of it happening or against it, the favor of it happening? All right, so if we have odds in favor, if that's what they ask for, then we follow this formula right here, this proportion. We want the number of outcomes in the event that we desire over the number of outcomes not in the event that we desire. So number 9 here, we want to know the odds in favor of rolling a 10 when we have this die that has sides 1 through 20. All right, so out of all those possibilities, the only thing we want, the only desired outcome is a 10. So that's one possibility. So that's the odds of the event happening, or the number of outcomes in the event that we want. The number of outcomes not in the event that are not a 10 is 19. All right, so this is different from probability. And if they had asked us to find the probability of rolling a 10, we would have said 1 out of 20. All right, because in that formula, we're putting the total number possible as the denominator. In odds, we're going to put the number that we want on top, the number of outcomes in the event that we're asking for on top, and the number not in it on the bottom. So number 10, in favor of rolling a number less than 6. So there are 5 numbers less than 6. So that's the number of outcomes in the event we're asking for. The number of outcomes not in that event, so the number of outcomes that are not going to be less than 6, is 15, the remaining 15 numbers. All right, and then we'll reduce that to 1/3. So 1 out of 3. These numbers can also be written, sometimes you'll see odds written as with this colon in the middle. 1 out of 3. Okay, this one 1 out of 19. All right, so they can be written either way. Now, if the directions ask us to find the number against, the odds against an event occurring, we're just going to switch the numerator and denominator. So now the number of outcomes not in the event is going to be the numerator, and the number of outcomes in the event will be the denominator. So number 11 asks us to find the odds against rolling a 1, 3, or a 5. So out of 20 numbers, the number of outcomes not in that event is 17. So that will be our numerator. The number of outcomes in the event is just those 3 numbers, 1, 3, or 5. This one can't be reduced, so we just leave it as 17 over 3, or you could write it, 17:3 as well. Either one is fine. Number 12, again, against rolling a number greater than 13. So we're looking for the number of outcomes not in the event. So we're talking about a number greater than 13. Right? There are 13 numbers not in that event. And there are 7 numbers in that event. 7 numbers that are greater than 13. Again, this one's not reducible, so we'll just leave it as 13 over 7 or 13:7. All right, so moving to the back of the sheet, we are moving back to the idea of probability. Find the probability that a dart thrown at the square target shown will hit the given region. Assume the dart is equally likely to hit any point inside the target. Round your answer to 3 decimal places. So they want us to go back to probability, which means we're going to, the equation formula for that is the number of outcomes desired divided by the total number of outcomes possible. And so we're going to find the probability in number 15 of the dart hitting the center. So circle A. So that would be our desired outcome. And any little point inside that circle counts. That is, so there's every little point inside the circle is an outcome. So if we find the area of that little circle, then that's going to be our numerator, the number of outcomes desired. You can see here that they've drawn in this arrow here to show the radius, and these arrows are pointing in there to show you that each of those radii, each segment there is 2 inches in length. So for our area of our circle, we know it's pi r squared. So for my center circle there, that A circle, my area is going to be, the radius is 2, so 2 squared. So for pi, that's the outcomes that are desired. Now, for probability, we want to know what the total number of outcomes possible are. So we need to find, if you throw a dart, it could hit anywhere on this dartboard. So the total number of outcomes of where it could possibly hit is actually the area of the entire square. So we know the length here is 24, width is 24. So the area of that rectangle is just 24 squared. Okay, or 576. All right, so we have the area of our circle. That's our desired outcome. We have the total number of outcomes possible in this 576. So we're going to set 4 pi as our numerator, 576 is the denominator, and then when we divide that out, we will get 0.022. So this is the probability of the dart hitting the center circle. So you can see how low that is in comparison to the entire, hitting the whole square instead. 16 now, we want just the border. So we're talking about just the F border, not the circle at all. So if we're talking about our number of outcomes desired, what we're looking for then is just this area right in here. So the way to find that is we want to disregard the circle in here, the area of the entire circle part of the dartboard. So if we take that total, the 576, and we subtract out the area of the center circles, then we're going to get the area of just the border, which is the outcome desired. That will be our numerator. So if we write that out in words first, the area of the border, F, so the area of F, we're talking about this right here, which is just corresponding to the border, is going to equal the total area of the square minus the area of circle E. All right, and the reason I'm saying circle E is because that's our largest circle here. So if we find the area of this, then we're going to find the area of all of those interior circles as well. All right, so let's find the total area first. So we're talking about this right here, the length times the width again. So 24 squared, 24 times 24, we figured that out in the problem above. It's going to be 576. All right, we're going to subtract from that the area of circle E. So we're going to subtract from this. We need the radius because it's a circle. So here's the radius, 2, 4, 6, 8, 10. 10 is our radius. We're going to square it because that's what the area of a circle formula is, and say pi. All right, pi r squared. We're going to stick the 10 in for r, square it, and then we end up with 100 pi. So if we subtract the two of those, we're going to get the area of F, just the border. And that should come out to 261.84. So that just the area of F is 261.84. So we're talking about all this grayed out area that I'm shading in here as blue. All right, that whole thing is 261.84. That's our desired outcome in number 16. So that's going to become our numerator. According to our formula over there, the number of outcomes desired goes in the numerator. The total, so the entire square together, we know is 576. All right, divide those out, and you'll get the probability of hitting the border as 0.455, which is a lot higher than we found the probability in number 15 of hitting the center, which was 0.022. So now here in number 17, they've just added in the word or, and they want to know what the probability of hitting the center A or the ring B. So out of the entire board, 576, that's our denominator still. What is the likelihood? What's the probability of hitting either A or B? It doesn't matter which one. So really we're just talking about what's the likelihood of hitting this circle here in comparison to the entire board. So now we're concerned about the area of circle B. So we're going to take the radius here, which is just 4. We're going to square that in order to follow our pi r squared formula. And so we'll get 16 pi for our numerator, divide those, and get a probability of 0.087. So you can see here that, up here we had 0.022 for hitting the center A. If we're going to hit A or B, the likelihood, the probability goes up a bit. And then hitting the border, it goes up quite a bit to 0.455. So you can it kind of makes the idea of a dartboard and the way it works in the point system maybe a little clearer based on the mathematics of probability.